Hello, grade 10 learners. Our new topic is on geometric sequence. At the end of this video lesson, the student should be able to define and illustrate geometric sequence, differentiate geometric sequence from arithmetic sequence, and find the end term of a geometric sequence. Now let's start. Let us begin with this activity. Determine if the sequence is arithmetic or not. If it is, find the common difference and the next term of the sequence. Recall that an arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. Let us find out if this sequence has common difference. So we can do that by subtracting the second term and the first term, and that is 8 minus negative 1, which is equal to 9. Subtracting again the third and the second term, and that is 17 minus 8, which is equal to 9. And subtracting the fourth term and the third term, and that is 26 minus 17, which is equal to 9. So therefore, this sequence is an example of arithmetic sequence. Now let us find out what is the next term. So it means that we need to add 9 to 26. That is why the next term is 35. Let us have another example. Given the sequence 2, 8, 32, 128, and so on, let us determine if they have a common difference. And we can do that by subtracting the second term and the first term. Equals 8 minus 2, and that is equal to 6. Subtracting again the third term and the second term, and that is 32 minus 8, which is equal to 24. Since it has no common difference, it means that this one is not an arithmetic sequence. Now let us use the same sequence, but on this case, let us try to change the operation into division. Instead of subtracting the second term and the first term, let us try to divide them. Let's see what will happen. So, dividing the second term by the first term, we have 8 divided 2, and that is equal to 4. Dividing again the third term by the second term, we have 32 divided by 8, and that is also equal to 4. Dividing the fourth term by the third term, and that is 128 over 32, which is also equal to 4. Now, to obtain the next term, we simply multiply 4, which is common to all succeeding terms. So we need to multiply 4 to 128. So the next term will be 512. So this type of sequence is called geometric sequence. Geometric sequence is a sequence in which each term after the first term is obtained by multiplying a non-zero constant. So, the number by which we multiply is called the common ratio, and it is represented by a small letter r. In this case, the common ratio is positive 4. Let us have the first example. Determine if the sequence is arithmetic or geometric. If it is arithmetic, find the common difference. And if it is geometric, find the common ratio. So I'll be giving you 3 seconds to do that. For number 1, we have 4, 9, 14, 19, and so on. 3, 2, 1, go. So this one is an example of arithmetic sequence. Now, let's try to find out their common difference by subtracting 9 minus 4 equals 5. 14 minus 9 equals 5. And 19 minus 4, which is also equal to 5. So it means that the common difference is equal to 5. How about the second sequence? We have 1, 5, 25, 125, and so on. 3 seconds to answer. 3, 2, 1. So this one is an example of geometric sequence. Now let us try to determine the common ratio by dividing 5 divide 1, which is equal to 5, dividing 25 divide 5, which is equal to 5 also, and dividing 125 by 25, which is also equal to 5. So it means that the common ratio is equal to positive 5. Let's deal with example number 2. Write the first 5 terms of geometric sequence whose first term is 3 with the common ratio negative 3. So in order to do that, let us begin by determining the first term. The first term is equal to 3. Now, to obtain the second term, we simply multiply the first term by the common ratio, and that is 3 times negative 3 equals negative 9. So the second term is negative 9. Now, to get the third term, we simply multiply the second term and the common ratio, and that is negative 9 times negative 3 equals positive 27. So the third term is positive 27. Now, to obtain the fourth term, we simply multiply the third term and the common ratio, and that is equal to 27 times negative 3 equals negative 81. Now, to get the fifth term, we simply multiply the fourth term and the common ratio, and that will give us negative 81 times negative 3, which is equal to positive 243. So therefore, the first 5 terms of the geometric sequence are 3, negative 9, 27, negative 81, and 243. Now, let us determine the nth term or the general term of a geometric sequence with the first term a sub 1 and common ratio r, defined by a sub n equals a sub 1 times r raised to n minus 1. So, now let us try to work on with this example. Find the 10th term of the geometric sequence 6, 12, 24, 48, and so on. So on this case, we need to identify first the common ratio, and that is achieved by dividing any term to the number that precedes it. So on this case, I'll be using the second and the first term. So the common ratio is equal to 12 divided by 6, and that is equal to 2. So the common ratio is 2. Now, the first term here is 6, while the number of terms is 10. So, by substituting all these values to our general rule, so we have here a sub 10 equals 6 times 2 raised to 10 minus 1. So we simplify first the exponents. We have 10 minus 1, and that will give us 9. And then we raise 2 raised to 9. So we have here 512. So the result, 512, we multiply it by 6. That is why the 10th term is equal to 3072. Now, let us deal with another example. Find the general term and the 8th term of geometric sequence 64, negative 32, 16, negative 8. So, we first find the general term, and we can do that by finding or identifying first the common ratio. Common ratio can be obtained by dividing the second term and the first term. So we have here r equals negative 32 over 64. So the common ratio in lowest term is negative 1/2. Now the first term, for the first term, it is equal to 64. Now by simply substituting these values, the r and the first term, which is a sub 1 to the formula. A sub n equals a sub 1 times r raised to n minus 1. Then we have a sub n equals 64 times negative 1 half raised to n minus 1. This is now the nth term or the general term of the given geometric sequence. Now, let us find the eighth term. So, to find the eighth term or the a sub 8, we just simply substitute the r, the values of r, a sub 1, and n. N here is equal to 8. So, we have a sub 8 equals 64 times negative 1 half raised to 8 minus 1. So, we work on the exponent first, which is 8 minus 1, and that gives us 7. Now, simplifying the exponents, we have negative 1 half raised to 7, and that gives us negative 1 over 128. And then this one, negative 1 over 128, we simply multiply it by 64. We have negative 64 over 128. Getting the lowest term, we have negative 1 half. So it means that negative 1 half is the eighth term of the geometric sequence 64, negative 32, 16, negative 8, and so on. Let us have another example. The common ratio of geometric sequence is 1/4 and the fifth term is 1 over 1024. What is the first term? So in order to find the first term, we have to identify first the ratio or the common ratio, which is equal to 1/4. The last term or the a sub n is 1 over 1024. So in this case, we are looking for the first term or a sub 1. So for the solution, we simply substitute all the values, the given values to the formula. So it gives us 1 over 1024 equals a sub 1, which is missing, times 1/4 raised to 5 minus 1. Since 1 over 1024 is the fifth term, that's why the value of n here is 5. Now simplifying the exponent, 5 minus 1, it gives us 4. Now simplifying the exponent, 1/4 raised to 4, then we have 1 over 256. So, to solve for the value of a sub 1, we simply divide both sides of the equation by 1 over 256. There we go. So, it gives us 1 over 1024 divided by 1 over 256. So, to simplify this, we simply copy the numerator, which is 1 over 1024, and then we get the reciprocal of 1 over 256. That is why a sub 1 is equal to 1 over 1024, and the reciprocal of 1 over 256 is 256. And then we simplify this. We have a sub 1 equals 256 over 1024. And in lowest term, a sub 1 is equal to 1/4. It means that the first term of the sequence with the common ratio 1/4 and the fifth term 1 over 1024 is equal to 1/4. Now let's try this. What is the common ratio of the geometric sequence 4, negative 8, 16, negative 32, and so on? Is it A, 2, B, negative 2, C, 4, or D, negative 4? Example 2. The first term of geometric sequence is 5, and the second term is 30. What is the fifth term? Is it A, 180, B, 1080, C, 6480, D, 38,880? For the next one, find the 12th term of the geometric sequence 1, 2, 4, and so on. Is it A, 512, B, 1024, C, 2048, or D, 4096. So, until here, until our next session, thank you and enjoy learning.